Hi, my name is Ansley. Today I will be using SPSS to demonstrate how to perform a one-way ANCOVA test using the ANCOVA example 01 dataset in order to determine if there is a significant difference in standardized test scores between Brown's, Jones, and Smith students when controlling for periods missed. My covariate for this study is periods missed. My hypothesis is that there is a significant difference in student standardized test scores among the classes taught by Brown, Jones, and Smith when controlling for periods missed. My null hypothesis is that there is no significant difference in student standardized test scores among the classes taught by Brown, Jones, and Smith when controlling for periods missed. Before conducting my one-way ANCOVA test, I must first check the homogeneity of regression slopes to verify that the relationship between the covariate and the outcome are the same age group. To do this, I will open my data in SPSS. We'll go to Analyze, General Linear Model, Univariate. Then I will add Test as my dependent variable, Class as my fixed factor, and Periods missed as my covariate. Then I go to Model and Build Custom Terms. I'm going to move Class down and then click Add, Periods missed down and then click Add, Class down by Periods missed, Add, Continue. And OK. I make this bigger. Now, in reviewing my output, I'm looking for my factor by covariate row right here, class times period missed. And I can see that the p-value is 0.488. As p is greater than 0.05, the assumption is met, and I can proceed with my one-way ANCOVA test, during which I will also check for homogeneity of variance, my other pretest assumption. To do this, I'm going to go to Analyze, General Linear Model, Univariate. This part is still set up correctly, but I need to make some adjustments here. I'm going to go to Model, Full Factorial, Continue, EM means, class over, compare main effects, and I'm going to select for the confidence interval adjustment von Braun. Continue. And then options, I'm going to select homogeneity tests, estimates of effect size, and descriptive statistics. And I'm going to click continue and OK. And all my data has come into my output. So let's review it. First, I want to review my homogeneity of variances. I'm going to zoom in again, and I need to go to the next page. Here it is here. This is my second pretest assumption that I need to check. And I can see here as the p-value for the Levine's test is 0.691, which is greater than 0.05. The assumption for homogeneity of variances is met. Now, in reviewing the output, I will find the test of between subject effects box right here. And under the source column for factor, which is class, I can see that I have 2 degrees of freedom with 86 degrees of freedom for the error. F, back to my class row, is 4.116, and the significance is 0.020. As the significance value of 0.020 is less than 0.05, I reject the null hypothesis that there is no difference between the classes when I control for periods missed. When I review the adjusted means in the estimates box down here, I can see that, which is controlled for periods missed, I can see that Smith has a mean score of 84.097, or rounded up 84.10. Jones has a mean score of 79.93, and Brown has a mean score of 80.47. To further understand this, I will review pairwise comparisons, which are on the next page. And I can see that there is a significant difference between Smith and Jones, as the significance value is 0.029, which is less than 0.05. However, between Smith and Brown, I do not have significance, as it is 0.075, which is greater than 0.05. Likewise, for Jones and Brown, we do not have significance, as it is 1. Lastly, I want to review my partial eta squared. I'm going to go back to my previous page and again look for this class row. and find my partial eta squared score, which is 0.087, which represents a medium to large effect size, indicating that the effect size is practically meaningful. Now to report my findings in APA format, I'm going to go back to Word. A one-way ANCOVA was conducted to determine if there was a significant difference between test scores among Smith, Jones, and Brown when controlling for periods missed. Students were randomly assigned to one of three classes. The independent variable or fixed factor was the class. The dependent variable was the test score, and the covariate was periods missed. Preliminary checks were conducted to ensure that there was no violation of the assumptions of homogeneity of variance, p equals 0.691, nor of the homogeneity of regression slopes, p equals 0.488. The one-way ANCOVA demonstrated that there was a statistically significant difference between the three classes test scores when controlling for the number of periods missed, F with 2 degrees of freedom and 86 degrees of freedom for the error equals 4.12, P equals 0.020, partial eta squared equals 0.087. As P is less than 0.05, I reject the null hypothesis. The partial eta squared value of 0.087 represents a medium to large effect size, indicating practical differences between one or more classes. Pairwise comparisons indicated that Smith's class, mean 84.10, standard deviation 6.27, and Jones's class, mean 79.93, standard deviation 5.61, had significant differences in test scores, p equals 0.029. However, pairwise comparisons between Smith and Brown's classes, Brown, mean 80.47, standard deviation 6.28, they were not significantly different, p equals 0.075, nor were differences significant between test scores in Brown's and Jones's classes, p equals 1. These findings are practically meaningful because they show that instructional differences between teachers are associated with a medium to large difference in students' test performance, even after accounting for periods missed. The significant gap between Smith and Jones's classes suggests that adopting more effective instructional practices like those used in Smith's classes could lead to several point gains in achievement for entire groups of students. Thank you.